All right, we are going to create and interpret histograms here in this here video. So first things first, the histogram. Remember that a histogram is a graph of touching bars, right? So it's a bar graph, but it's a special type of bar graph because we are dealing with continuous data. And because the data is continuous, the bars will touch or be adjacent. So in a histogram, we can show the shape, center, and spread of data. And when you're looking at the histogram, the horizontal axis is going to be the numbers, the values of what we are talking about. So if the ounces of blood in the body, the number or ounces of water I drank in a day, or whatever else is continuous. Vertical axis is the frequency. So how many times does it happen, or the relative frequency if we want to look at the proportionality of something. Okay, so first I want to talk about interpreting histograms first. And that simply means what can we tell just by looking at the graph? So if I'm looking at a histogram, this histogram represents the heights of black cherry trees. And height is continuous, right? There's no definitive stop and starting point between values. So the interpretation of this graph, just what do we see? Well, the highest, the most frequent, or the mode of the data, lies somewhere between 75 and 80 feet, right? That bar is the tallest, so somewhere between 75 and 80. That is the highest one that is shown most often. We would say that maybe this is skewed left because that highest bar, it'll tail more to the left. There are 3 bars to the left. That kind of is symmetrical. But we would say, the heights range anywhere from 60 to 90 feet. 90 feet is the lowest bar, so it's the least amount seen. Generally, the 2 highest bars between 70 and 80. So just different things that you can see. We're talking about frequency, so that's the number of times things appear. So you can see that highest bar, the mode 10. There are 10 trees between 75 and 80 feet. That's what we get from that piece. Okay, so interpreting is just what do you see? Okay, now constructing the histograms can be a little bit more in-depth, tricky. So first you have to determine how many bars do you want. Between 5 and 15 is best practice. I try to keep it somewhere between 5 and 7, just my own personal preference, especially if I'm doing it by hand. Then we're going to choose the starting point for the first interval. Generally, I take my smallest data point, boom, that's where I'm starting. Now, if the smallest data point is 2, generally we don't want to start at 2. We want to start at 1.5. So we're going to take it 1 decimal place further. And the reason we do that is because if we have a boundary point that's, let's say, 7, and you have the number 7, what bar does that go in? If that 7 is touching 2 bars, it's hard to distinguish between one from the other. That's why we take it out from decimal places. We're going to choose the endpoint, which is larger than the large data value. We'll talk about that in a minute. We have to calculate the width of each bar, and they all need to be the same. So we do that by taking the endpoint minus the starting point and then dividing that number by the number of bars. We're going to then define our boundaries, and we'll draw the graph according to frequency. Okay, so let's do this. Now, the first one we're going to do is pretty easy, okay? So we're going to use the following data to construct a histogram on the ounces of liquid Cindy spilled each month over the last 20 months. So I've organized the data for you. And if you don't have organized data, you're going to want to do that first. So I've organized it. We have 20 numbers. Now, it's pretty easy to see. There are 6 numbers, pretty clear. I'm going to use 6 bars, and I'm going to make each one of them just 1, like the distance of 1. So really, we can skip quite a few of those steps because we don't have wide range of values. So I'm going to start at 4.5, okay? And I'm going to go up by 1. So you'll notice that the 5s will go in that spot because 4.5 to 5.5 represents the 5 bar. Okay, then we're going to go to 6, 7, 8, 9, and 10. So 10.5 is bigger than my biggest value, so I'm fine. And now look at the frequencies. So we've got a 5, a 5, a 6, 2, 1, and a 1. Frequency simply means how many times does each one of those numbers appear. So 1, 2, 3, 4, 5, 6. So that's just, those are the tick marks. So we can do our frequency. Okay, so now we're going to start with the 5s. We have 5 of them. So I'm going to go up to 5 and create my bar. Now, because I'm making this by hand, it's a little crazy. But you're going to notice that those bars touch. For the 7 spot, we're going to go up to 6. For 8, we go down to 2. 9 is 1. Oops, I didn't go far enough around there. And 10 is 1. Now, generally, we would have a title. So, like, Cindy spilled some stuff. And down here would be like ounces. We want to label things, and this would be labeled frequency, right? And that's the basis of a pretty straightforward, easy histogram. But unfortunately, not all histograms are that easy. So let's look at this one. The data is all over the place. Our smallest number is 3. Our biggest number is 51. Yay. So I'm first going to say, you know what? I want to do 5 bars. Okay? So that's my first thing, right? Choose how many bars you want. I choose 5. And then I'm going to say, okay, I'm going to make my lowest number 2.5 because 3 is my lowest data point. If I just go half less, right, because we want there to be a decimal. Now, when I think of my biggest number, 51 is my biggest. I need it to be greater than that. Now, remember, I'm going to divide by 5. So I'm going to take my starting point, my end point minus my starting point, divide by 5. Guys, it's easier if you don't have like major decimals. So think, what is a number bigger than 51 that is divisible, like when you subtract 2.5 is divisible by 5? Well, don't make this too difficult. If I just make it 52.5, when I subtract my numerator, I get 50, which means my intervals are going to have a width of 10. Okay, so that's kind of how we figure that out. And I always choose a number right bigger than your largest data point. That helps this be divisible. And sometimes I have to do a little guess and check, right? Subtract, divide. Ooh, that doesn't work. Try something else. Okay, so we know they're going to be 10. The width is 10. So I have my, okay, I'm going to start at 2.5. Pretend that's a 2. And then we're going to add 10. So 12.5 is my next boundary. 22.5, 32.5, 42.5, and last is 52.5. Okay, so then we're going to go up 1, 2, 3, 4, 5. Okay, hopefully I don't need more than that. So now when I'm looking, how many numbers are between 2.5 and 12.5? 5, 3, 5, 7, 9, and 10 are between 2.5 and 12.5. So this is going to have a frequency of 5. My next one is between 12.5 and 22.5. I have 3 of those, so I go to the 3 line. Again, my bars touch. Between 22.5 and 32.5, I don't have any, so that's a 0, and that's okay. That happens. Between 32.5 and 42.5, I have 4, so this one goes up to 4. And then between 42.5 and 52 is also a 4. And this is the histogram for that. So again, you might want a title. You might want to label your sides, but that's the basic idea if you need to use some other types of groupings.